Hello friends and welcome all to the next topic of airport engineering. Today's topic will be taxiway design. I myself, Tushar Patel, Assistant Professor from the Department of Civil Engineering from the college Mahatma Gandhi Institute of Technical Education and Research Center, Navsari. Now, as Dennis Weltley rightly said, all of the top achievers I know are lifelong learners looking for new skills, insights, and ideas. If they are not learning, they are not growing and not moving towards excellence. So, my dear friends, I would like to say that move towards excellence, not towards money. So for the today's topic, we have the following contents. I'll first describe about what is taxiways, the factors controlling the taxiway layouts, the geometric designs of the taxiway, what are known as exit taxiways, the aprons and the hangars. Taxiways. The main function of a taxiway is to provide access to the aircrafts from the runways to the holding, loading, apron or service hangars and back. Runways, passenger and cargo terminals, aircraft storage and service areas all are linked by the taxiway system. The components of the taxiway system serve as a transitional media between the aerodrome functions necessary for optimum utilization, maximum capacity and efficiency of an airport. The taxiway system should be designed to minimize the restriction of an aeroplane movement to and from the runway and the apron areas. A properly designed taxiway should be capable of maintaining a smooth continuous flow of aeroplanes, ground traffic at the maximum practical speed. On busy airports, the taxiway system should also allow aeroplanes to exit the runway as soon as possible after landing and to enter the runway just before the takeoff. As you can see in this figure, the yellow portion shows you the taxiway. This is a proper diagram or a proper schematic diagram for a given taxiway in a given airport. Now moving forward to the factors controlling the taxiway. In planning the layout of a taxiway system, these are some of the factors that should be kept in mind. Taxiway should be arranged that the aircrafts which have just landed and are taxiing towards the apron do not interfere with the aircrafts taxiing for takeoff. The taxiway routes should be connected the various elements of an airport by the shortest distance, thus minimizing the taxiing time and cost. These routes should be as simple as possible to avoid need for complicated instructions and confusion to the pilots. As far as possible, the intersections of the taxiway and the runway should be avoided. At busy airports, taxiways should be located at various points along the runway so that the landing aircraft leaves the runway as early as possible and keep it clear for the use by other aircrafts. Such taxiways are also called as exit taxiway. Exit taxiways should be designed for high turnout speeds. This will reduce the runway occupancy time of aircraft and thus increase the aircraft capacity. Taxiway routing should have one-way operations as far as possible to minimize the aeroplane conflicts, delays and interferences. Taxiway system should be planned for a phased development so that the future additions are easily possible. These taxiways should be as straight as possible. The taxiway routes should avoid areas where public could have easy access. This is for the security of the taxiing aeroplane from sabotage. All the sections of the taxiway system should be visible from the aircraft control tower. Lastly, Taxiway layout should be planned to avoid interference with navigational aids by taxiing aeroplane or ground vehicles using the taxiway. Now, what is geometric design of a taxiway? It is the function of speed of an aircraft on the taxiway is much lower than its speed on the runway during the landing or the takeoff. Thus, the design standards for a taxiway are not as rigid as they are for a runway. There are some recommendations done by the ICAO. These are the following elements of the taxiway geometrics: the length of the taxiway, width of the safety area, longitudinal gradient, transverse gradient, the rate of change of longitudinal gradient, the taxiway curves, side distances, the turning radiuses, and the stopping distances. These are some of the recommendations done by the International Civil Aviation Organizations. Now moving forward to the length of the taxiway. Now what is the length of the taxiway? The length of the taxiway should be as less as possible. No standard specifications are recommended by any organization for limiting the length of the taxiway. As far as possible, for the width of the taxiway, it is observed that the width of the taxiway is much lower than the runway width, as the aircraft is not airborne and the speeds are small. The width can be varied from 22.5 meters and 7.5 meters. Now, as you can see in this table, it is a classification done by an ICAO on 5 types of aircrafts: A, B, C, D, E, having different types of taxiway width, maximum longitudinal gradient, maximum transfer gradient, maximum rate of change of longitudinal gradient per 30 meter, and the safety area width. So accordingly, for A, the taxiway width will be around 22.5 meter. It is approximately 75 feet. For B, it will be 22.5 meter. For C, it will be 15 meter. That is approximately around 50 feet. For D, it is 9.9 meters. And for E, it will be 7.5 meters, approximately 25 feet. So these are the lengths and the widths of the taxiway. Now moving across to the taxiway cross section. This is an area shown in the figure below, shows the taxiway pavement shoulders on either side that may be partially paved plus the area that is graded and drained. Now why this is necessary? These areas include the taxiway pavement. Now, before the advent of jet aircrafts, mind well, jet aircrafts, the shoulders were of natural ground protected with low growing vegetations. But because there is a problem of erosion due to the jet aircrafts, due to its high speed jet exhaust, it has become more complex. Hence, it is felt that certain widths, say for example 7.5 meters of the shoulders adjacent to the pavement edge, should be paved with light strength material. This figure shows you this width of the safety area. Now moving across to the side distance, as per ICAO, it recommends that the surface of the taxiway must be visible at least up to a distance from X from a point at a height of Y above the taxiway surface. So in the table we have where change in a slope of a taxiway cannot be avoided. The change should be such that the surface of the taxiway must be visible from 3 meters height for a distance of 300 meters for a aircraft type of A, B and C, and from 2.1 meters height from a distance of 250 meters for D and E type of aircraft. This is sight distance. Next, moving across to the taxiway curves. Now, wherever there is a change in the direction of the taxiway, a horizontal curve is provided. The curve is so designed that the aircraft can negotiate it without significantly reducing the speed. Circular curve of a radius of large is suitable for this purpose, right? So the radius of the circular curve is obtained by the equation r equals to v square divided by 125f, where r is the radius of curve in meters, v is the speed of an aircraft kilometer per hour, and f is the coefficient of friction. F is a constant having a value 0.13. Now this figure shows how the aircraft goes from a pavement where a supersonic transport with a wheelbase of 31.2 maneuvers a curve of 60-meter radiuses. You can see in this figure, for the aircraft serving large subsonic jet aircrafts, minimum value radius of the curvature is 120 meters, whatever may be the speed. This shows you the taxiway radius. So, we'll try to solve out the sum of the taxiway radius. Now, the question is to determine the turning radius of a taxiway if the speed of the aircraft is 93 kilometers per hour and coefficient of friction is 0.13. So, as we know, what is the formula? The formula is R is equal to V square divided by 125F. We have V, we have F. So the answer will be near about the radius in meters will be around 533 meters. Now next moving across to the exit taxiways. Now what are exit taxiways? The function of an exit taxiway is to minimize the runway occupancy time by landing the aircraft. The location of the exit taxiways depends on the following functions. The location of a taxiway is determined by the deceleration rate of the aircraft after crossing the threshold. To determine the distance from the threshold, the following following factors are required. First is the number of exit taxiways, the exit speed, the type of aircraft needed, the weather conditions, the topographical features, and the pilot variability. Now I'll explain one by one everything. What is number of exit taxiways? If there are only two exitways, they would naturally be provided at the runway ends. If there are more number of exitways, these are distributed along the runway length. Next comes the exit speed. The aircraft requires a certain length of runway to reduce its speed from the landing speed to the exit speed, that is the turn off speed. Thus, the exit speed also affects the location of the exit taxiways. Next is the type of aircraft. Now, different types of aircraft land at different speed. Therefore, the distances required by different aircrafts to reduce their speed in the taxiway varies with the type of aircraft. This in turn affects the location of the exit taxiways. Next, we'll move across to the weather conditions. Now, wind, temperature, fog, etc. affects the landing speed of an aircraft. Thus, the landing speed affects the location of the taxiways. Next are the topographical features. High altitude or deep valley reduce the visibility, which may affect the landing speed, which in turn affects the location of the exit taxiways. Lastly, pilot visibility or pilot variability. The rules for flying transport are relatively precise, but even then, a certain amount of variability among pilots is bound to occur, especially in respect to the distances from the runway threshold to the touchdown point and in application of the brakes on the runway. This is the pilot variability. Now moving across to the aprons. Now what are aprons? It is a paved area for parking of the aircraft, loading and unloading of passengers and cargo. In that we have a type known as holding apron. Now sometimes they are also known as run-up or warm-up pads, which can be defined as an area where an aircraft can be held or bypassed to facilitate efficient surface movement of an aircraft. Now these aprons have the loading and unloading aprons types. Now, in a case of a smaller airport, the air traffic may not be sufficient to justify the construction of parallel runways. So, in those cases, then what we provide is the turnaround taxiway. As you can see in this figure, this is the figure showing you the turnaround taxiway where the taxiing is done on the runway itself and a turnaround is provided at the end of the runway strip. So that is the condition which is termed as the turnaround taxiway. These also serve the purpose of holding aprons. Different parts of an airport, as we have already studied in the previous topics. These are the hangars, the terminal building, the control tower, helipad, the runway, the taxiway, and the apron and ramp. This figure will give you a total insight of the different parts of an airport that are to be used by an individual aeroplane, passengers, and loading and unloading of cargo. Now next, moving across to the size of an apron and its gate position. Now the term gate is used to denote an aircraft parking space adjacent to a terminal building and used by a single aircraft for loading and unloading of passengers, baggage and mail. The size of an apron depends upon the three categories, three factors. First is the size of an aircraft. Second is the aircraft parking configuration. And the third will be the manner in which the aircraft enters and leaves the gate position. Now, airport parking configurations. Now, aircrafts are parked causing least interference due to heat, fumes, and blast during maneuvering into and out of the gate positions. Jet engines are more critical in this respect than the piston engine aircraft. So the basic parking configurations are nose in parking, angled nose in parking, nose out parking, angled nose out parking, and the parallel parking. These are the basic parking configurations. Now I would like to say the advantages of nose in and angled nose in parking. These require less apron area, less noise while taxiing. Hot blast is not directed towards the terminal building. The aircraft forward door is close to the terminal building and better passenger handling in terms of safety, convenience and comfort. But there are some disadvantages with these two types of parking. Which two types? Nose in and angled nose in. The disadvantages are the aircraft rear loading door is far away from the terminal building. It requires large power with maneuvering the loaded aircraft out of that gate position. Now there are advantages of nose out and angled nose out parking also. The rear loading door is close to the terminal building. It requires less power while maneuvering the loaded aircraft out of that gate position. Less apron area is required. The main disadvantages of nose out and angled nose out parking is that the hot blast is directed towards the terminal building itself. Lastly, for the parallel, advantages is both the front and the rear doors can be used for loading and unloading of the passengers. But disadvantages are it requires a large gate position area, it requires relatively long loading bridges, and the hot blast and the noise are directed towards the adjacent gate positions. So, my dear friends, the basic parking configurations are classified into 5. I have explained the advantages and disadvantages of all the 5 types of parking facilities. Next, moving across to the aircraft parking system. The various methods of grouping aircraft adjacent to the terminal building are referred to as the aircraft parking systems. These are of 4 types: the frontal systems, the open apron systems, finger system, and the satellite system. Now, I have shown you all the figures, right? The frontal system, open apron system, finger system, and the satellite system. So what do you mean by a frontal system? In this system, the aircrafts are parked along the face of the terminal building. It is very simple and economical system, but its use is limited only to a small airports requiring few gate positions. In open apron system, it is also known as the transporter system. In this system, the aircrafts are parked away from the terminal building. This is shown in this figure. Access to the aircrafts with this system is by the motor transporter. Sometimes the passengers have to walk long distances to reach the aircraft parked in the outermost row. They are thus exposed to the weather, noise, and hot blast of the air jet crafts. Moving across to the finger system. Now, what is a finger system? See the figure closely. In this system, the connection of the aircraft to the terminal building is achieved through the types of piers or fingers. Now, the piers or the fingers can be fenced, open walkway, or a closed structure, single or multi-storied. It can be straight, T-shaped, or Y-shaped. Last system is the satellite system. Now these are the small buildings located on the apron. Aircrafts are parked around the satellite building, which are connected to the main building by underground channel. This system is in use in the international airport of Los Angeles. So my dear friends, Los Angeles is one type of airport which we have as a satellite system airport. Hangars. Now what is a hangar? The main function of a hangar is to provide an enclosure for servicing, housing, and repairing of the aircraft. As you can see in this figure, an aircraft is hanging in the hangar. They are usually constructed of steel framework covered with a galvanized iron sheet. The service hangars are provided with the machine shops and stores for spare parts. The size of a hangar depends on the size of the aircraft and its turning radius. Sometimes the ceiling of a hangar and some portions of its side walls are glazed, which work as a light reflectors. The number of hangars depend upon the peak hour volume of the aircraft and the demand of the hangar on the rental basis by different airline agencies. These are used for the protection from the weather, protection from the direct sunlight, maintenance, repair, manufacture, assembly, and storage of the aircraft on airfields and aircraft carriers and ships. Now, it is very desirable to locate the hangars as near as possible to the terminal building and the loading aprons. Thus, the requirements of suitable hangar site are: first, it should have convenient road access from the apron and the terminal building, reasonable proximity to the loading apron. It should be linked with the essential facilities such as electricity, water supply, telephone, etc. It should have a reasonable, favorable topography providing good natural drainage. It should have a sufficient area to provide car parking facilities for working personnel. It should have adequate site area for future expansion of other hangar facilities. And lastly, the site should not be along the direction of frequent windstorms. Now moving forward to the general planning considerations of an hangar. The shape of an hangar should be such that it covers the minimum land area and provides adequate space for the storage and comfortable maneuvering of the aircraft. We'll discuss the two types of hangars, the T-shaped hangars and the nose hangars. Now, what are the T-shaped hangars used for? These are provided for small size of aircrafts. In this design, the storage space is so arranged that the pilot can maneuver the aircraft in and out from the hangar without any assistant. The area should be such that a minimum clearance of 30 centimeter is available on all the sides of the aircraft. Now look at this figure. The figure down shows you the T-shaped hangars. Next is the nose hangar. These are provided for bigger aircrafts. As you can see in the figure, it is a nose-shaped hangar. They enclose only the forward portion of the aircraft and leave the major portion of the fuselage and the tail surface exposed out. Such a design provides comfortable working conditions for servicing and engine haul of the aircraft. This design is very much economical. So today we have studied about the taxiway designs, the factors affecting the taxiway, the exit taxiways, the basic parking configurations, and the hangars aprons. So my dear friends, I'd like to thank you all for being so silent and for being so much competitive. Thank you. Have a nice day.